In oxidative cleavage, an alkene is cut and an aldehyde or ketone is in its place in the product. So we're not going to worry so much about regiochemistry or stereochemistry. Let's just look at a couple of examples of what this looks like. These are examples of ozonolysis. It's actually possible to do other types of oxidative cleavage. And indeed, we looked at one when we did our anisine reaction. So we'll look back at that in a second. But now what happens here is that the alkene is actually cut in each of these places or in each of these cases. And where the alkene was now has an oxygen. So in some cases that will lead to a ketone, in others an aldehyde. It's possible to cut a cycle, in which case you will wind up with two carbonyls in the same molecule. And Klein offers a way to figure out what the product will be. He says, either draw like kind of a squiggly line or actually erase with your eraser right in the middle of each of those alkenes, and where you've just erased, put an oxygen on either side, and that gives you the product. So as I mentioned, you did actually do this reaction in the lab where you use potassium permanganate to oxidatively cleave an alkene. You actually wound up with a carboxylic acid in this case, and probably carbon dioxide as your other products.